Silicon has been around long enough. It's time for a younger and far more fit challenger to take over semiconductor material dominance. Gallium nitride power devices are smaller, faster, more reliable, and comparably priced. At this point, there are few reasons not to use GaN FETs and ICs. The Gan Talk podcast is a series of interviews with the people behind the rise of gallium nitride in power electronics. This interview-style podcast series talks to the visionaries, leaders, researchers, and engineers using gallium nitride to disrupt the power electronics industry.
Hello and welcome to Efficient Power Conversions, Episode 3, GaN Introduction to GaN and Motor Drives with Marco Palma. Very excited to have Marco on the show today, the Gan Talk podcast. GaN is very important and playing a very important role in motor control. GaN-based motor drives are being adopted for e-mobility, bikes, scooters, and more, power tools, satellite reaction wheels, robotics, and drones, because GaN provides smaller, lighter, and more efficient solutions. The fast switching speeds of GaN-based motor drives enable precise motor control, improving efficiency and responsiveness. And GaN's reduced conduction and switching losses lead to less heat generation, allowing for smaller and more reliable motor drive systems. Today's guest, Marco Palma, joined EPC in 2019, where he is Director of Motor Drive Systems and Applications. He has over 20 years of experience in motor control power electronics, ranging from switches to gate drivers, controllers, and algorithms. For International Rectifier, Marco worked on the smallest 13 kilowatt fully integrated and programmable motor drive power modules in 2002, the first industrial sensorless FOC controller IC in 2004, the smallest 100 watt fully integrated fan drive module in 2009. For Infineon, Marco worked on the smallest programmable 100 watt fully integrated motor control power module in 2018. He's the author of several articles and patents in the field of motor control. Marco received an MSEE from Politecnico di Torino and MBA from Bocconi Milano. I probably pronounced that wrong, so I apologize.
Yeah, you did it. You did it correctly. You did it correctly.
Welcome to the Gan Talk podcast. Thank you so much for joining.
Thank you, Rick. Thank you, everybody. Listen to the podcast.
So this is important in some questions that we have. We're going to get right into it, some of the questions, because I know our audience, they want to understand about GaN. Where is GaN in motor control? I mean, motor control is ubiquitous. There's a few questions that we have here. So let's just start with our first question. Can you explain the fundamental differences between GaN and traditional silicon-based semiconductors, in the context of motor drive applications?
So the first thing is, if you compare a GaN FET, the way it switches versus a MOSFET, you have several things that are in advantage for the GaN FET. There's no reverse recovery because there's no body diode. There is a diode, equivalent diode function, but no body diode. And the reverse recovery, especially in motor drives, it's really hurting a lot in terms of losses and also EMI. And then the switching is smoother than a MOSFET, and there's less ringing. Also, this is making clean waveform in the motor drives, with just some advantages. We can talk about it. And also, another important thing is, due to this, the way it switches, the GaN FET, then enable the designer to increase the PWM frequency and to reduce to the point that we can consider negligible at that time. And this is giving clearly advantages to the motor, but we can go through the details on that.
Okay. So Marco, what initially sparked your interest in GaN technology for motor drives? I know you've worked with silicon, obviously, at International Rectifier and then Infineon in the past, but why GaN? Why are you now interested in GaN? I know you're doing a lot of work at your lab in Italy. What sparked your interest in GaN technology for motor drives?
The main point is, I started with high voltage IGBTs, then I moved to I would say medium voltage MOSFET, then I went to low voltage MOSFET. And the one thing that it was really hurting me, especially with the MOSFET, was that I couldn't raise too much the PWM frequency. I said, why would you raise the PWM frequency? The reason is there are some application where you must do it because you have such a low inductance in the motor that if you don't do it, you get a lot of ripple, the motor overheats, and then this is giving problem. There are other applications where simply the designer they always been working with this limitation. They do not see what's after that limitation. And the motor are designed in a way that if it can drive them better, they are more efficient. So when it came to the gallium nitride, they say, okay, now things, this is changing, the story is changing because uh, the R switching and the frequency are not anymore a limitation, okay? So we can do more things, and that's where I started doing the research here in the R&D and in the lab, in the application lab here at EPC, and then that started everything.
That's interesting, and I think before we get on to the next technical question, I actually wanted to ask you that because I wrote this note down. So in Italy, EPC has two facilities dedicated towards motor control and IC design. So there's the application center. I believe it's near Turin. That's where you're located.
Yeah, it is.
Right?
Yes.
Yeah. And then there's the IC design center, which is south of Milan.
Right.
So
right.
EPC has invested in this region. And I think it's just fantastic. I think it just shows the growth of GaN. It shows the focus on motor drives. And these are how many people are in your facility in Turin there right now? And
so in this moment, we are 9 people. Some of them are external because we have PhD students and we have master thesis students, and then we have people doing internship, and then we have direct employees working as application and firmware applications engineers. This is the application center near Turin. And south of Milan, in the IC Design Center, there are, I think in this moment, there are 8 people. There are IC designers, layout, test engineers, characterization engineers. There's the IC design director. And the reason we invested over here, because for sure, there are the competencies historically and but we are really investing on the worldwide asset. Okay, so we're not just looking at the Italian or the European market. Especially with the application center, we're really covering the motor drive application all over the world.
that's fascinating. I think it just really shows the way that the GaN is being accepted and growing. You know, EPC being a leader in gallium nitride, low voltage gallium nitride, investing in opening these design centers. So let's get into one of the technical advantages of questions that we had for you, Marco. And most folks out there now, most engineers that are working with silicon would say, so what are the advantages of GaN transistors compared to silicon, and silicon carbide in motor drive systems?
So you can start really summing up into, first of all, figure of merits. Okay, if you take all the classical figure of merits of switches, including conduction, R switching, soft switching, all the figure of merits you can take, area, then you will see that the gallium nitride definitely beat the other technologies. So the silicon limits has already been breached, and now it's a little bit overcome with the 3D structure, but still it's far from what is the theoretical limit for the gallium nitride. Then the other thing which is important is that you get a smaller RDS(on) for a smaller device. And the way we do it, because basically what we're doing, we are enhancing a lot to reduce as much as possible the thermal path from the active surface area to the point where you extract the heat. So you can have a better thermal, smaller RDS(on), and better switching that helps in getting higher efficiency.
Okay, so how does GaN then contribute to the overall efficiency of motor drives? Because I mean, there are some motor drives that that are really not meant to be efficient, right? There's other motor drives. I think we talk about brushless DC that have to be very efficient, that have to be precision. We've seen those in medical robots where EPC has had, some designs in automotive. But how does GaN contribute to the overall efficiency of these precision motor drives?
Yeah, usually when a motor is designed by the motor designer, I'm talking about sinusoidal motors, which are, the brushless permanent magnet sinusoidal motors become the vast majority. They already are the vast majority. And they are designed with a sinusoidal, clean, clear sinusoidal excitation in mind. But then what power electronics engineers do, they feed in square waves, ringing square waves, like, for instance, with MOSFET inverters. And the motor itself can be driven better and become the same motor more efficient, simply because with a gallium nitride inverter, you can get a cleaner waveform with lower total harmonic distortion. And also, the fact that you can increase the PWM frequency helps in removing the electrolytic capacitors. And this is also giving a higher power density, higher reliability, because they're also the electrolytic capacitor point of failure in terms of time. So there are several advantages, even in those motors that usually customers say, oh, my motor, I don't need to drive it a very high PWM frequency. That's wrong, simply because they never measure the real impedance of the motor. If you measure the impedance of the motor and go beyond the classical 20 kilohertz, there are motors that they have optimum operation at 50 or 80 kilohertz, 100 kilohertz. The reason that this has never been done is simply because there was no chance to go higher in frequency with previous technologies.
Yeah, that's interesting. And I guess following up on that question is what are some of the current applications of GaN technology in motor drives, and what impact is it having on those industries right now that you're seeing?
Yeah, we're working a lot with servo drives because we can making them more compact and with higher power density. What is really happening is that when you do a gallium nitride based inverter for a servo drive, in the same cubic volume, you can have a higher current than before. Or if you want to have the same current as before, because your application requires same current, then you can reduce the volume of the inverter and the case, and especially the parts which are really hurting most are the box and the heat sinks. And some type of application, really, the volume is already predefined. And given that volume, the more current you can give, the better it is. That's what gallium nitride is enabling. Then delivering more current in servo drive is one thing that is helping a lot, but also we're seeing a lot good effect in all those battery-driven applications. When you have a battery, given today's technology of batteries, you have basically weight, and inside that weight, there is some charge. And if your system is inefficient, you have to increase the weight because you need to store more charge. So efficiency is really a key, and in that sense, gallium nitride can help a lot.
I see. So in which application areas, and I know there's quite a few, do we see GaN, or do you see GaN making the most significant impact in the near term, and why?
I would say, yeah, in the battery operated applications, because again, it's really key. It's kind of a trade-off between weight, efficiency, and so consider, for instance, a drone application. In a drone, you have the structure of the drone, then you have the battery. And when the drone is empty, the highest weight is given by the battery cells, and in part also by the inverter. So you may have an hexacopter, okay? And if you have a drone that needs to lift heavy loads like 30 kilos, 50 kilos, or even medium load like 10 kilos, Really, the flight times depends on a trade-off between the weight of the battery, the efficiency of the motor. And in those type of application, all these power tools, for instance, is the time when you're working, you need to remove the battery to place another battery because you want to keep working. And if you have a more efficient and better tool that is easier to use and also is weighing less, that is really, really helping a lot. So all these battery operated application, in my opinion, will start having more and more GaN penetration, gallium nitride penetration in the short term.
Okay, that's interesting. Let's talk about challenges and solutions now, right? There's always that for the power electronics engineer. Uh, what are the main challenges in designing and implementing a GaN-based motor drive?
If you compare to conventional way of doing the design, um, I would say the number one difference is that when you start a power electronic converter with gallium nitride, you have to think in terms of heat and where the heat goes. So it's first of all is a thermal design. You need to know with your mechanical engineers and your system expert what is your thermal budget, how much heat you can remove from your system. And from that, you do the design going to the electronics and then to the gallium nitride. Historically, using MOSFET has always been the opposite, okay? You do the inverter and then you try to find the thing that fits the power dissipation you're doing. And since you have the chance of having a higher efficiency, now things have to do in the opposite way. Okay, what is my thermal budget? I can dissipate, let's say, 300 watts. Okay, then I need to design the converter or the inverter so that I don't exceed my thermal budget. And then I choose the proper GaN FET. And one common myth, especially in motor drive, is, oh, RDS on. You need to have the lowest resistance RDS on because motor drive is all RDS on. Again, from system level point of view, that's fake. That's wrong. What really makes is important is the efficiency of the motor at a given frequency and the efficiency of the inverter at a given frequency put together. So it doesn't mean that the optimum of the one is the optimum of the entire system. Maybe you choose a suboptimal frequency for the inverter and for the motor, but then you got an optimal for the system. And that is then driving of the rest. Maybe for that frequency, a slightly higher RDS on is better because you have lower capacitance and then lower switching dissipation. So this type of things are now becoming more and more important. And in fact, those customers who control the entire system from battery to inverter to motor, are those customers which are really finding the real benefit of gallium nitride. Those customers that see only just one portion are still a little bit reluctant, but eventually they will come too.
Yeah, that's fascinating. Let's talk about future trends and innovations right now. Obviously, you're doing a lot of work at your design center there in Italy. Can you share with us, you and your team, any breakthroughs on research and findings with GaN technology that could significantly impact motor drive designs moving forward?
Yeah, if you look at it from motor point of view, okay, the way the motor are designed are made in a way, the copper winding have to withstand the current which is needed. Then you have to have the proper magnetic design to deliver the torque that is needed. And then you need to have a magnet grade which can withstand the temperature that you're gonna get in that kind of operation. And usually motor designed with a sinusoidal excitation in mind, but then they never excited it sinusoidally. What what is coming out is that by using gallium nitride inverters, you can get a more efficient operation of the motor. That means having the motor running cooler. And some of our customers are already thinking to change the magnet grade because they don't need higher magnet grade for that type of operation because the temperature they're going to reach is lower. And this is giving advantages. Some other customers are simply realizing that the same motor modified slightly by having a gallium nitride inverter in mind can deliver more torque or can be cost optimized. So this is the point that really will become a tipping point by the moment also the motor makers understand that driving in the right way, the motor can be further optimized.
Okay, that's great because that leads right into my next question about market adoption and industry impact. How do you see the market adoption of GaN in motor drives, say over the next 5 to 10 years?
It looks to me like, whenever you have a new technology, it takes a while before it substitutes the previous technology, but then it starts like rolling rocks, then it starts going. And I foresee that the GaN will do the same that MOSFET did with the bipolar, okay? So that will be widespread across applications. And this is going to happen for sure in the next 5 to 10 years. And you can already see it. If you take a charger today, mobile charger, laptop charger, they are all of them GaN-based. Okay. In the same dimension, you can get higher efficiency. And this is becoming more and more in the small compact servos. These are all GaN-based. Humanoid robots where you need a lot of joints, you need a lot of efficiency. You don't want to have too much heat and you want to have power, impulsive power. That's GaN.
Yeah, that's a very good point. So, Marco, what industries do you believe will be most transformed by the widespread adoption of GaN and motor drives? Now, you just mentioned, robotics. You've talked about drones, and we know those. I mean, are there any other industries that you believe will really benefit and see the real benefit of GaN?
I mean, if I think about e-mobility in general, not only car with a big traction inverter, e-mobility in general that goes from even small cars or cars with hub motors in the wheels, and whenever there is the need of having higher efficiency compactness, and there are batteries, there is where I see gallium nitride having the biggest impact. And in this case, I'm talking e-mobility, including flying objects. In the industrial automation, in terms of autonomous vehicle within the production line, so you can have two types of production line. Either you have a logistics center, as an example, that was born to be completely fully automated. That's one case. That's the extreme case. Or you have a fully human-centered system, or you can have a kind of hybrid. And in my opinion, in the mid-sized companies, the hybrid will be the dominating factor. And so you cannot design the factory in a way that only is very specific autonomous vehicle can go inside. So you need to have some kind of hybrid approach, including, for instance, humanoid workforce. And all these things require efficiency because battery has to last longer between charge cycles. It's where I see the GaN motor drive becomes predominant.
Yeah, that's very interesting. Let's go over now to there's a couple more questions here. A vision for the future. All right. How do you envision the role of GaN technology in the future of sustainable energy and electric transportation?
The main thing is that when you have a new toy, you start playing new games. Okay. And gallium nitride helps really in reducing the switching energy, dissipated energy. That enables some other topologies. And there's one important thing that I said at the beginning of the interview or the podcast. There's no reverse recovery. And we working currently here in the application center. We're not working only on motor drives. We also work in other applications. Anyway, we're working on a multi-level inverter for traction motor drive. And at the same time, we're working also at a multi-level power factor corrector from AC to DC. And by doing analysis and looking at figure of merits of the multi-level structure, multi-level topologies, clearly comes out that reverse recovery plays a very bad role. So if you have switches with reverse recovery, the multi-level structure doesn't help you too much. However, if you have a switch like gallium nitride FET that doesn't have reverse recovery, and then you start stacking them in a flying capacitor multi-level structure as an example, you start getting advantages of the fact that the switching energy which depend on output capacitance remain the same as if you had the conventional T level, while you don't have any reverse recovery losses. And if you then do the math and start combining the figure of merit together, then you will see that a 4-level base gallium nitride FET 200-volt devices can really beat in terms of the figure of merit and then efficiency a 2-level silicon carbide and a 2-level high voltage MOSFET. And okay, you will say, okay, but then I can do it a 4-level MOSFET, low voltage MOSFET, but then 4-level low voltage MOSFET doesn't work because of reverse recovery. So I see new topologies coming out because the right direction is to get higher efficiency. And I see also that something is going to change in the terms the motors are used. Because today it tends to have one big motor doing everything. I could foresee more distribution also of motors, hub motors in the wheels of small vehicles instead of having one big motor, one big inverter. Those things can really happen, in my opinion, and starting to happening already right now.
Yeah, there really is, isn't it? We are seeing that. Okay, so Marco, the final question for you on today's podcast, Gan Talk podcast. What is your ultimate vision for the future of GaN in motor drives, and what steps are needed to get there?
We've been talking all the time on how to use the gallium nitride transistor inside inverters, which are 3-phase, 2-level. Then we started saying, okay, let's put many levels so to increase the voltage and put them. There's still one thing that is really different from motors if you compare to other converters, okay? Motor stayed, I will say, since more than 100 years, always 3-phase. Since their inception, they stayed 3-phase. There's no reason to stay 3-phase. If motors start evolving with the technology and the motor makers start making a motor in a more efficient way that can exploit the use of the gallium nitride capabilities, this can also be a really important thing. For instance, there are already studies, especially in traction system, but not only, of having multiple phase motor, not just 3-phase. And the way motors are designed need to be changed considering the way the technologies that are available today and how they can evolve in the future. Because remember that also gallium nitride technologies is a lateral technology which allows having integrated circuit in a single die. That's what we do at efficient power conversion. We do half bridge with a gate driver and high side and low side power GaN FET in one single device. And 3 of them can do a motor drive. But in the future, you could have a more distributed system with many motor phases and having small integrated circuits driving high power motors simply because you're distributing the power the way you're driving. And also you increasing the redundancy in that sense for reliability point of view. So I foresee this is also going to happen in the future.
That's exciting. It really is when you think about all the opportunity for GaN to make an impact with efficiency, as you were saying. So, well, that's all the questions that we have. Thanks for joining us on our third episode of Gan Talk, Marco. The Gan Talk podcast is a series of interviews with the people behind the rise of gallium nitride in the power electronics industry. This interview-style podcast series talks to visionaries, leaders, researchers, and engineers in the power electronics industry, like our guest today, Marco Palma. If you would like to learn more about EPC and EPC gallium nitride products and motor drives, please visit our website. It's at epc-co.com. Marco, again, thank you so much for your time today.
Thank you, Rick. Thank you, everybody. Thank you.
Thank you.
Thank you. Bye.
Bye-bye.